So, chemical kinetics. Chemical kinetics is one of the major area which will tell you how the reactions are obtained, how the reactants are creating or generating the exact products, and what are the factors, and everything comes under the area of chemical kinetics. Let's move on from GTech company. Here is the index. I'm going to talk about the chemical kinetics, the rate and order of the reaction, what are the characteristics of order of a reaction, what is molecularity of a reaction. These areas I'm going to discuss now. Let's move on. So here are some of the important areas I'm going to discuss now. The rate and order of the reaction. So what is the order of the reaction? Which one should process first? This one first, second this one, third this one. And what is the speed of rate? These things I'm going to discuss now. And also the order of the reaction, as I told, which should be first and which should be next. And what speed the reaction should start and should end. And the molecularity of a reaction. What could be the effective molecularity, or how much it should be changed or should have to do some process. So these things I'm going to discuss now. And also there are a lot of variety of characteristics to define the order of the reaction. I'm going to talk those things now. So, chemical kinetics. The knowledge of rate of chemical reaction is valuable to understand the chemistry and mechanism of reactions. The study of chemical kinetics includes the experimental determination of rate or speed of a reaction, the rate law and the effects of concentration, temperature, pressure, and the catalyst affecting the rate of the reaction. These areas I am going to discuss now. It is possible to deduce the mechanism of the reaction from the chemical kinetic data. Chemical kinetics help us to understand how the chemical reactions occur. Chemistry by its very nature is concerned with many changes. Substances with well-defined properties are converted by chemical reactions into other substances with different properties. So here is on the Le-Chatelier principle. You are able to see if the pressure is more, you are able to see automatically the work done is really more. When compared to the work done, you are able to see here there is an increase in value or work. Similarly, if there is an equilibrium, considering I got an equilibrium, you are able to see the weight or direction will move based on the weight of the object in one size. This is referred to as stresses. It will happen due to change in concentration, changes due to the pressure, or it can be changes to the temperature. Let's talk about the reversible reaction. Reversible reaction is nothing but A mixed up with B will form C and D, and it will go back once again. If the reactants, the input is more, automatically the product is really lesser. You are able to see now it's balanced. This is how the equilibrium reaction will be. From here to here or here to here it will happen. That's referred to as equilibrium reaction. If the product is really more, automatically you are able to see it will become the reactant, so it will become equilibrium. So this is referred to as equilibrium reactions. You are able to see once the product is moved or something like that, automatically a replacement will be there. Now it is imbalanced now. You are able to see it has become equilibrium. Automatically the products will be created to maintain the equilibrium position. Now I got the product here more. This is taken. You are able to see the product is created to maintain the equilibrium. Now I got a change in pressure. What it will happen? It's a hypothetical reaction. A plus 2B, which is giving C and D. I got a pressure now, increase in pressure, decrease in volume. So less space. The equilibrium will shift to the side of the reaction with fewer moles. You are able to see under pressure, here 2B is there, 1A, C and D is there. This is the reactants and this is the product. So more volume now, more space now. So increase in pressure favors side with the fewer moles. Decrease in pressure will favor side with the more moles. For chemical reactions, a chemist should try to find out the following factors. So the feasibility of a chemical reaction, which can be predicted by thermodynamics, has known that a reaction with a delta G less than 0 at a constant temperature and pressure is feasible. So extent to which a reaction will proceed can be determined from chemical equilibrium. The third point is the speed of the reaction, the time taken by a reaction to reach the equilibrium position. Let's move on to a typical experiment in GTech laboratory with iodine. I got a 10 ml of a 2.0 m of sulfuric acid in a large beaker, and I've added a 10 ml of 3% hydrogen peroxide now. So I want to dilute it with 100 ml of water. I'm trying to dilute it. Now I diluted it. Now let's move on to a small beaker. It's a jar kind of beaker. I've added all the things into the jar. Now solution of a 0.04 gram of sodium thiosulfate pentahydrate in 20 ml of water. Now solution of 0.9 gram of potassium iodide in 5 ml water. I'm adding 4 ml of starch solution now. Now we have to dilute it once again with water now. I'm trying to dilute it. So this is water. So I'm trying to add the entire solution into the old solution now. I put it in the jar. I got it. The two mixtures are poured together. You are able to see there is something happening. The bubbles are coming in. You are able to see there is some agitation happening in the beaker, and the color is getting changed. A bluish and thickest bluish, and it's becoming a kind of a black color. So, along with the feasibility and extent, it is equally important to know the rate and the factors of controlling the rate of the chemical reaction for its complete understanding. The word kinetics is derived from the Greek word kinesis, meaning movement. Thermodynamics tells only about the feasibility of a reaction, whereas chemical kinetics tells about the rate of the reaction. So, for example, thermodynamic data indicate that a diamond shall convert to graphite, but in reality the conversion rate is really slow, so that the change is not perceptible at all. Therefore, most people think that a diamond is forever. Kinetic studies not only help us to determine the speed and rate of a chemical substance or reaction, but also describe the condition by which the reaction rates can be altered. The factors such as concentration, temperature, pressure, and catalyst affect the rate of the reaction. At the macroscopic level, we are interested in amounts are reacted or formed and the rates of the consumption or formation. At the molecular level, the reaction mechanism involving orientation and energy of molecules undergoing collisions are discussed. So, here I am going to deal with the average and instantaneous rate of the reaction and the factor affecting this. Some elementary ideas about the collision theory of reaction rates are also given. In order to understand all this, let us first learn what is the reaction rate. Let's start it.